Hi, and welcome to the Castline Systems Cable Calc overview tutorial video. In this video, we're going to look at the main features of Cable Calc and run through a simple calculation to produce a calculation report. If you don't already have Cable Calc, you can sign up for a month's free subscription at castlinesystems.co.uk to give it a try. So this is the supply details tab. Here you set all your source information for the supply. So phase, voltage, impedance, etc., as well as what type of circuit you're trying to calculate, whether you're feeding fixed equipment or socket outlets, and your permitted volt drop, load, distance, etc. You can set default values for these from the Cable Calc defaults, so that it automatically uses a default value of impedance or PSCC each time you do a new calculation. So on the cable tab, we select the type of conductor we're using. So we'll just switch that to 90-degree steel wire armoured and direct in ground. And you can select the number of cores and the size of the cable that you're using here. And it's worth noting as well that at any time you can press the cable up and cable down buttons from any tab to increase or decrease the cable size. Here's the correction factor tab, where we set any correction factors that we've got if we need to correct for any ambient temperature correction, or for example where you've got more than one cable for cable grouping, etc. Onto the protection tab. Here you set your circuit protective device. So in this case we're just going to leave that at an NCB. You've got all the different types of protective devices here, as well as user-defined devices that you can select. The circuit protective conductor, so you can select here through the options of cable sheath or armour where applicable, whether you want to use an internal core for the calculation as well, whether you want a separate cable with the various options to allow it to calculate a minimum size for the cable. Use table 54-7, or you can manually select the size of the separate CPC from the list. So you can then move on to the time tab, which just shows your fault current against the disconnection curve of the protective device, so you can just see where it falls on the curve. Once you're happy with all that and you've got a pass in the top right, you can click View Report, create PDF for this circuit, then you can add various headings, etc. to it, and then you get a detailed cable report of the calculation with all the various details on it there. So this is the supply tab. Here you set the phase of the calculation. You can choose between single, three-phase or three-phase and neutral. The voltage, and if you alter, for example, the single-phase voltage, then it will reset the three-phase voltage to the square root of 3 of that accordingly. Your source impedance. Now obviously it's very important for an accurate calculation to have an accurate value of source impedance. Without that you're guessing a little bit when it comes to achieving disconnection with your protective device. Your prospective earth fault current, this will always be calculated via Ohm's law from your impedance and your voltage, and then your PSCC, which will often be a value quoted by the electricity board, which you could use as a check value against the maximum breaking capacity of your protective device. You select whether you're doing an AC or a DC calculation, and your system earthing arrangement as well, be that TNCS, TNS or TT. The type of circuit, so Cable Calc will calculate radial, ring, submain, lighting, both ordinary lighting calculations and single and three-phase street lighting as well, as motor direct online calculations and star delta. You can select whether you're feeding fixed equipment or socket outlets. Your disconnection time will always be calculated for you, which is based on your load and the type of circuit it is. And you can click the little info button next to that just to get a breakdown of how that's worked out for you. You can select whether you want to provide overload and short circuit protection for your circuit, or just short circuit protection, and also set a maximum permitted volt drop for the calculation. Here you can enter your load and the distance. For ring circuits, this is always the distance to the furthest point. For other circuits, it's the length of the cable in total. Your load in amps. If you're doing a three-phase calculation, then this is always the load per phase. You can also convert a kilowatt load into amps by clicking the button and entering the number of kilowatts. Click OK, and it will convert that into amps for you at the current voltage. This is the cable tab, where you select the conductor that you want to use for your calculation. You can select based on the insulation type from the list here. So you've got thermoplastic, PVC, LSF, XLPE, rubber, fire resistant, etc. We'll just select an XLPE one there. And here you can see that we now got the option to rate it to 70 degrees if your accessories are only rated to that, so you can use the 70 degree table in BS7671. You select the number of cores and the size of cable you want to use, or you can click calculate minimum size to select the minimum size based on your load and volt drop. And you can also choose your installation method from the list here. This is the correction factors tab when you set any relevant correction factors for your calculation. For example, if you want to apply a grouping factor, if you go back to cable and change your installation method, then you'll see that the available correction factors change to take that into account. If you want to apply a factor, just select it from the list. In this case, we'll just select a grouping factor of 3, which gives us a 0.65 correction factor. And if we just evaluate that, we can see that applied to the cable rating there, which now takes that under the permitted size for that cable. This is the protection tab. Here you can select the device that's providing fault protection for your circuit. You just select the device type from the list here, and then your rating on the left. For the molded case circuit breakers, you've also got the additional options to reduce the thermal setting or derate the breaker, and the magnetic setting, which you can use to adjust the curve of the device. Most of them are adjustable, some are fixed, in which case you'll need to know the magnetic setting from the manufacturer on that side of things. You can also select whether your circuit is additionally protected by an RCD, and whether you're going to use that for automatic disconnection of supply or just for additional protection, in which case it will use the circuit breaker's maximum permitted NS. You can also use your own user-defined devices. If you've got level 4, then there's an option here to manage your user-defined devices, where you can add new devices to the list. This is the CPC tab, where you can select the circuit protective conductors that you're using for your circuit. You've got the choice of using cable sheath or armor where applicable, an internal core in the cable or a separate cable, where you've also got the option to either calculate the size, use the same size as the cable, selected according to table 54-7 from the regulations, or you can select the size yourself, in which case you also have the option to have parallel cables for your CPC. If you're running steel conduit or trunking, then you have the option there to include that in your CPC calculations as well. And there's also the option to enter manufacturer's value of energy let through data, I²T. For this, you would need to read off the manufacturer's graph for the fault current, which will be shown here, and enter their value of I²T there. And that will then reduce the size of the circuit protective conductor. Usually it's particularly useful in low impedance situations, when you're using a reduced CPC cable, such as twin and earth or something like that. And lastly, we have the time tab that shows you a plot of the device's disconnection curve and where your fault current falls on that. You can see when you change the protective device, changes the curve and shows you where your fault current hits it, and gives you a display of your disconnection time there as well. Thank you for watching this cable calc tutorial video. Please visit the Castline Systems YouTube channel for more tutorial videos. If you've got any questions or you'd like to contact us about anything else, then you can email us on support@castlinesystems.co.uk or get in touch via our Facebook page.